A cantilever beam is subjected to completely reverse bending moment of 200 Newton meter. The log S versus log N diagram for the beam is shown below. This graph is a versus log and log. So this one is 10 to the power 3, 10 to the power 6. Log to the base 10 of 10 to the power 3 is same as 3, and log of 10 to the power 6 to the base 10 will be equal to 6. And this value is same as our SM, but log of SM, and this one is log of SE. The diameter D of the beam for a life cycle of 10 to the power 5 cycle we have to calculate. We have given here the case of bending, and we have given the value of bending moment equal to 200 Newton meter. So bending moment M is given equal to 200 Newton meter. So this equation is same as our Baskin equation, which is given as fatigue stress S is equal to a constant A multiplied by N and power is B. In the Baskin equation, the constant A is given as SM square by SE, and the constant B is given as minus 1 by 3 log of SM by SE to the base equal to 10. So we'll take the log of this equation on both sides to the base 10, and we'll substitute for this, and we'll find out the constant A and B. So let's say this point equal to point A and this point is equal to B. So in this case, the point A here represents the log of 10 to the power 3 to the base 10, comma, log of SM to the base 10. And this value is given to us as 3, 2.687. Similarly, we can record the point B. We have point B is same as log of 10 to the power 6 to the base 10, comma, the corresponding value represent here the log of endurance strength to the base 10, and is equal to 10 to the power 6 to the base 10 will be same as equal to 6, and log value of SE is given as 2.093. So we'll use the Baskin equation, that is we have S is equal to A into N to the power B. So take log on both sides. We have log of S to the base 10 equal to log of A to the base 10 plus we have B times log of N to the base 10. So two equations we can find out here, and we have two constants, one is A and one is B. So we are comfortable to solve it. Log of A into N to the power B is same as log of A plus log of N to the power B, and log of N to the power B can be written as B times log of N. So if we solve this value for the A point, in that case we have log of S is equal to 2.687. 2.687 log of A to the base 10 will be as it is, plus we have constant B, and log of N will be equal to 3. That is, we have 3 times of B. Second point for B, we have log of S is 2.093, that is the endurance strength, is equal to log of A to the base 10 plus we have 6 times of B. So we have minus, minus and minus. 2.687 minus 2.093 is positive value 0.594. Log of A will be get cancelled, and 3B minus 6B will be equal to minus 3B. So if you solve it, you will get the value of B is equal to minus 0.198. Now we'll put this value of B either in equation 1 or equation 2, and we'll solve for A. So let's select the equation 1. We have 2.687. 2.687 is equal to log of A to the base 10 plus we have 3 times of B. So we have 3 times of B is minus 0.198. So solve this, you will get a constant A is close to 1909, and therefore the given equation is S is equal to A is 1909 into N, and power is B, which is equal to minus 0.198. Using this equation, we can calculate the stress developed, that is the fatigue stress developed for 10 to the power 5 cycle. So this one is 5 means 10 to the power 5. Correspondingly, we can calculate here the fatigue strength equal to S. And this value of S will treat as a sigma B value. That is a bending stress value. So for N is equal to 10 to the power 5 cycle, we have bending stress will be maximum value here, because whenever we are is a completely reverse loading, we have value of sigma amplitude is same as equal to sigma max. This value is same as sigma max, and corresponding value here will be sigma minimum. And this is the problem of bending, so this value will be same as our sigma bending maximum will be equal to 1909. Number of cycles we are using as 10 to the power 5, and we have power is minus 0.198. Solve this, you will get a maximum bending stress produced will be corresponding to 10 to the power 5 cycle is 195.4 megapascal. We are interested to know the diameter, and we have circular section. So we have maximum bending stress in the case of circular section subjected to bending moment M is given as 32 times M by pi d cube. And we have maximum bending stress produced is 195.4 equal to 32. Bending moment is given as 200 Newton meter. That value you have to take as Newton mm. So you have to multiply by 10 to the power 3, and whole thing is divided by pi into d cube. So only unknown in this case is the diameter, and we can evaluate the diameter d is equal to approximately, this answer is close to 21.8 mm. So there is hardly given a difference in the numerical whether we have given a plot of log directly, or we have given the value of SF and SM directly. It doesn't matter. Our process will remain same. Here we have developed the equation first for Basquin. This one is a straight line equation. So we'll just take a log on both sides, and we'll find out here the two constant A and B from the two known value at point A and point B. To find the equation of a straight line, two endpoints are necessary, and using this we can develop the equation for the Basquin. Once we know the value of A and B, then for 10 to the power 5 cycle, we have find out the value of fatigue. Because of completely reverse loading, we have sigma A will be same is equal to sigma max, and this value of sigma max will be equal to sigma bending maximum. And in case of bending moment, the maximum bending moment for a circular section is given as 32 m by pi d cube. Hence, we are successfully able to find out the value of diameter equal to 21.8 mm. The fatigue life of a material for a fully reverse loading condition is estimated from equation sigma amplitude equal to 1100 n to the power minus 0.5, where sigma A is the stress amplitude in megapascal and n is the failure life in a cycle. So indirectly we have given here the Basquin equation. The maximum allowable stress, that is the amplitude in megapascal for a life of 1 into 10 to the power 5 cycle under the same loading condition we have to find out. Remember that we have Basquin equation, which is given as S equal to A into n to the power B. Here instead of S, we have used here sigma A also. We have sigma A is equal to A, constant A is 1100 into number of cycle, and the constant B is given as minus 0.5. We want to calculate here the amplitude stress for a life of 10 to the power 5 cycle. So simply substitute for n equal to 10 to the power 5. So in this case, we have amplitude stress will be equal to 1100. Number of cycle is 10 to the power 5, and we have power is minus 0.5. So in one simple step, we can find out here the amplitude stress, and we have amplitude stress is close to 195.6 is megapascal. We know that for fully reverse loading, the cycle will start from 0, will attain a maximum value that equal to sigma max, then attain a value of 0, then attain the value of sigma minimum, and finally will attain a value equal to 0, and this cycle is repeated. So this value corresponds to here the maximum stress, and the lower value will be equal to sigma minimum, and in this case sigma minimum is same as negative value of sigma maximum. Because of sigma minimum is minus sigma max, we have mean stress will be equal to 0, and the amplitude stress is measured from mean stress. So this value is same as amplitude stress, which is same as equal to the maximum stress. In this case, we have maximum stress is equal to sigma A is 195.6 megapascal. He is interested in the maximum allowable stress in amplitude is 195.6 megapascal. You will find number of questions are asked on the Baskin equation in the GATE examination. One question will take from exam 2017. A machine element has an ultimate strength SUT is equal to 600 Newton per mm square, and the endurance limit SE is equal to 250 megapascal. The fatigue curve for the element or log plot is shown figure. So we have 0.8 into sigma E is same as equal to SM value. That is the material strength at point A corresponding to 10 to the power 3 cycle, and endurance strength is same as our SE value, that is given as 250 megapascal. Maximum amplitude of a completely reverse operating stress we have to find out. So for this one we'll use the Baskin equation, which is given as sigma amplitude is same as equal to stress, that is the fatigue stress, equal to A multiplied by n to the power b. So let's collect the data here. We have given the value of SUT is equal to 600. So we have SUT is equal to 600. Therefore we have material strength SM, which is equal to 0.8 of SUT, that is equal to 0.8 times of 600 is equal to 480 megapascal. And the endurance strength SE is given as 250 megapascal. For 10 to the power 4 cycle will be approximately at this point, and correspondingly if we look at the point we can find out the stress, which one is same as the amplitude stress. For this one we have to find out the value of A and B. The constant A is given as SM square by SE. This time we have SM value we can substitute is equal to 480, and we have to take a square of it divided by endurance strength equal to 250. So we get a constant A here is close to 921.6. Constant B will find out as minus 1 by 3 log of SM by SE to the base 10. So that will be equal to minus 1 by 3 log of SM. SM is equal to 480. And endurance strength is equal to 250. We have to take the log of 10. So this constant will be close to minus 0.09443. So we are ready with that both constant A and B. Now we can calculate here amplitude stress. So we'll substitute here for constant A is equal to 921.6. Number of cycle we have to use as 10 to the power 4, and the constant B is minus 0.09443. Solve this, you will get the value of amplitude stress is very close to 386.2 megapascal. And one latest question will take from GATE examination 2021. The figure shows a relationship between the fatigue strength S and the fatigue life N of a material, that is the Baskin equation is shown on the figure. The fatigue strength for the material for a life of 1000 cycle, that is 10 to the power 3 cycle, is given as 450. So you have to treat here this value of SM is equal to 450. Well, its fatigue strength for a life of 10 to the power 6 cycle is 150. So the given value SE will be equal to 150. The life of a cylindrical shaft made of this material subjected to alternating stress of 200. So we have sigma amplitude is equal to 200 megapascal. and we have to find out here what will be the corresponding life. Naturally, this life is more than 10 to the power 3 and less than 10 to the power 6. On the log-log plot, we can use the Baskin equation as stress is equal to A into n to the power b, and the same value of stress you have to use equal to 200. Using the point A and B, we can find out here two constant A and B. Constant A is given as Sm square by Se. We have given the value of Sm is equal to 450. So we have 450 square and we have endurance strength equal to 150. In this case, we get a constant A equal to 1350. Secondly, the constant B is obtained as minus 1 by 3 log of Sm by Se is equal to minus 1 by 3 into log Sm is equal to 450 and endurance strength is equal to 150, that is the log of 3. So we'll get a constant here is close to minus 0.159. Now in the Baskin equation, we have known the value of stress that equal to sigma amplitude, which is equal to 200. So let's substitute sigma amplitude equal to 200, constant A equal to 1350 into number of cycles, and power B is minus 0.159. So the number of cycle is close to 163841. That will be number of cycle if it is subjected to alternating stress of 200 megapascal. The video you are watching is from the app, which is the Mohod class app available on Google Store, and in this app we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.